Hello student, this is the 16th part of matrices. So here I gave the syllabus for JEE Advanced, especially for matrices. Okay, matrices and rectangular array of real numbers, equality of matrices, addition, multiplication by scalar, and product of matrices, transpose of a matrix, determinant of a square matrix of order up to 3, the inverse of square matrix of order up to 3, properties of these matrix operations, diagonal, symmetric and skew symmetric matrices and their properties. All these completed, Nana. All these three parts completed, major parts. Okay, one more last part for matrices is, okay students, last part, important part for us, solution of simultaneously linear equations for 2 or 3 variables. Okay, already you know how to solve two linear equations simultaneously with 2 variables. For example, x plus y equal to 2 and x plus 2y equal to 7. You know how to solve these two. We have several methods. First method is elimination method, second substitution method, third one is cross multiplication method, fourth one is important method, graphical method. Because every linear equation of the form ax plus by plus c equal to 0 gives a straight line on the coordinate plane. So this represents a straight line, this also represents a straight line on the coordinate plane. Draw these two straight lines on the coordinate plane. If they intersect one another, we can say that there is unique common solution for these two equations, and that situation these two linear equations are called consistent linear equations with unique solution. Okay, sometimes one line may be fall on another, and that time you can say the infinitely many common solution. In this case you can say that these two equations are called two linear equations, consistent linear equations with many common solutions, or these two equations are called dependent equation. Sometimes those two will represent two parallel lines, so there is no common solution. In that situation the equations are called inconsistent linear equations. Students, important thing is here only 2 variables are involved. This is linear equation 2 variables. So we want solve to linear equation 2 variables. We need at least 2 linear equations in 2 variables. Then only you can find common solution. Okay. Now important thing is, students listen. What I did, one method, elimination method, substitution method, cross multiplication method, graphical method. 5th method also there. That is called matrix method. Actually matrices are invented, their main purpose of invention of matrices is to solve the system of linear equation. Not only for 2 variables, here 2 or 3 variables or more than 3 variables also can solve, but in our syllabus up to 3 variables. We can solve 3 unknowns with 3 variables. We can solve by using matrix method. Okay. Okay. Listen students. So yeah, solution of simultaneous linear equation in 2 or 3 variables. Just now explained, a1x plus b1y, okay, equal to c1, a2x plus b2y equal to, b2y equal to c2. These two are called two linear equations. While solving x and y simultaneously is solving a system of these two linear equations. We have several methods I explained. Okay. Now this will represent a straight line on the coordinate plane. If students, ax plus by plus cz equal to d, this is also a linear equation in 3 variables. So this is linear equation 3 variable. This is called non-homogeneous linear equation. So already we know that what is homogeneous and non-homogeneous. The homogeneous expression means all the terms should have the same degree. For example, ax plus by is homogeneous expression. Ax square plus 2hxy plus by square also homogeneous expression. For example, some c is added, this is non-homogeneous expression. Some k is added, non-homogeneous expression, because this is first degree, 0 degree. Second degree constant. That's why this is not non-homogeneous. What I wrote here, this is non-homogeneous linear equation. Okay. If d equal to 0, then this is said to be a homogeneous linear equation. Students, ax plus by plus c equal 0 represent a straight line on the coordinate plane. Ax plus by plus cz plus d equal 0 represent a plane on the space or in 3D plane. ax plus by plus cz plus d represent a plane on 3D space. Okay, now for example a1x plus b1y plus c1z equal to d1 and a2x plus b2y plus c2z equal to d2 and a3x plus b3y plus c3z equal to d3. Now I can call these three are three linear equations in three variables x, y, z. Here d1, d2, d2 also presented, no? So that's why I can say that these three are a system of non-homogeneous linear equations. If d equal to 0, what happened? D equal to 0, d1 equal to 0, d2 equal to 0, d3 equal to 0. Then what you will get? What you will get? I will write here again. a1x plus b1y plus c1z equal to 0, a2x plus b2y plus c2z equal to 0, or a3x plus b3y plus c3z equal to 0. Now I can call these three are the system of linear equations which are said to be homogeneous linear equations. How to solve system of homogeneous linear equations, how to solve system of non-homogeneous linear equations, that is our present concept. Just now I explained that ax plus by plus cz plus d equal to 0 represent a plane on coordinate in 3D space. So these three represent three different planes on 3D space. Okay, plane means the flat surface extending all the direction, just like our paper. This is one paper, this is another paper, this is another paper. If those three papers are coincide one another, you can say that there are infinitely many common solutions. Okay, so these three planes are intersect at one point. You can say that there exists a unique solution for these three linear equations. Okay, no. That means that the position of the plane, the number of solutions of these linear equations depend upon the position of the plane. But that concept I won't explain here. So just by using matrices method, I want to find the solution of a system of linear equations of two types. One is called non-homogeneous linear system, another is called homogeneous linear system. Okay, so here also, no, here also what you call this non-homogeneous, no? a1x plus b1y plus c1 equal 0, a2x plus b2y plus c2 equal 0. This line is not passes through origin, this also not passes through origin. Here also d1, d2, d3 not equal to 0 means these all are not passes through center of the origin of the space. Okay, this system, how to solve these three linear equations for x, y, z simultaneously, that is said to be solving system of a non-homogeneous linear equation. How to solve these three equations, how to find a common x, y, z which satisfied by these three equations, that is known as solving homogeneous system of linear equations. Okay students, two types. First of all, we need to complete this type, non-homogeneous linear, solving non-homogeneous linear equations matrix method. Okay. Okay students, first of all we want to identify what is the relationship between matrices and these equations. That is important thing. For example, a1x plus b1y equal to c1, a2x plus b2y equal to c2 are two linear equations, two unknowns. So these are linear equations, algebraic equations. Okay, but what is the connection between these two linear equations and matrices? Do one thing. Take a matrix, here one matrix. The matrix is 2 by 2 matrix obtained by the coefficients of these linear equations. Say here a1, b1, a2, b2, one matrix. Take another matrix with the variables xy. That to take in this way only. I will explain why you want to take like this. Okay, xy, and constant is taken as another matrix taken as c1 and c2. Student, do one thing, Nana. Multiply coefficient matrix with this matrix and equating to this, what you will get, observe. Okay, now I want multiply. This is 2 by 2, no? This is 2 by 1. I can multiply. The result is 2 by 1. Okay, see how I am multiplying. a1x plus b1y. This is first column. So a2x plus b2y. Okay, so should be equal to c1, c2. What is the meaning of this? a1x plus b1y equal to c1, and a2x plus b2y equal to c2 by the equality of two matrices. What is the meaning of that? If these two linear equations can be written in matrix form, that is the meaning. These two linear equations we can write in matrix form. Observe here. Sorry, here this one we can write in matrix form. Okay, if you multiply these two and equating this matrix, same linear equations are getting. That means this is said to be the matrix form of these two linear equations. Understood, students? For example, 2x plus 3y equal to 7 given, 4x minus 9y equal to 3 given. What is the matrix form of these two equations? Means I can say 2, 3, 4, 9, the minus symbol, xy equal to 7, 3. I can say this is the matrix form of these two linear equations. Multiply these two and equating these two, again you get same linear equation. Means reverse process, Nana. Reverse process. Okay. So now I established what is the relation between linear equations and matrices. So this matrix is generally known as coefficient matrix, because that matrix is formed by coefficients of x and y only. This is called variable matrix and this is called constant matrix. In general, coefficient matrix denoted by capital A, variable matrix denoted by capital B and capital X, and constant matrix denoted by capital B. So what you got here? Ax equal to b. So you got Ax equal to b. Coefficient matrix into variable matrix equal to constant matrix. Okay. Not only for two linear equations, for 3 unknown 3 linear equations, or 4 unknown 4 linear equations, or for n unknowns n linear equations, we can write them into matrix form. Okay, students, listen. A1x plus b1y plus c1z equal to d1. Okay. A2x plus b2y plus c2z equal to d2. Okay. A3x plus b3y plus c3z equal to, here 2, 2, 2, here 2 only, equal to d3. So 3 equations with 3 unknowns. Okay, so these are the 3 equations. How to write these 3 equations in matrix form? That is important. Matrix form of these equations. Just first of coefficient matrix, not cofactor matrix. Coefficient matrix A1, B1, C1, A2, B2, C2, A3, B3, C3. This is 3 by 3. Should multiplied with 3 by 3. No, 3 by something you want. 3 by 1 I want to take. 3 by 1 means here x, y, z. Should be equal to constant matrix, that is d1, d2, d3. Okay, students. Now what happened here? If this matrix is multiplied by this and equating this matrix, again you get same these 3 linear equations only. That's why this is called coefficient matrix. This is called variable matrix. This is called constant matrix. In general, coefficient matrix denoted by capital A. In general, A equal to A1, B1, C1, A2, B2, C2, A3, B3, C3. One thing. So capital X, variable matrix, X, Y, Z, and constant matrix, that is generally B, is equal to D1, D2, D3. So what is the relation and what is the matrix relation here? What I can say? A into X equal to B. This is the matrix relation between these 3 matrices. Okay. So if 3 equations with 3 unknowns given, you can write into matrix form. 4 unknowns and 4 equations are given, you can write into matrix form. That's not a big problem. Means n equations with n unknowns also you can write into matrix form. Okay. Now what I explained how to write a given linear equation to matrix form. Next, how to solve the system by using matrices. Okay. Listen all of you. Yeah, first one is major one. There are 2 types of system of linear equations. There are 2 types of system of linear equation. One is homogeneous. First, non-homogeneous better. non-homogeneous linear equations. Second one is homogeneous. Equations. So students, first of all we need to complete this part. After completion of this part only we'll start homogeneous. Just now I explained what is the standard form of non-homogeneous linear equation, 2 variables and 3 variables. Okay, so what methods are there with us to solve these system of linear equations? Actual matrix method, that too several methods are there. Generally we will say that matrix method, determinant method. Okay, one is matrix method, second is determinant method. Determinant, by using determinant concept you can solve. Determinant method. So first of all we need to use this first of all matrix method. I will explain how to solve a system of linear equation by using matrix method. Okay, yeah, matrix method. Let us consider the system of linear equation a1x plus b1y plus c1 equal to d. Right hand side your constant should be nana. Okay, a2x plus b2y plus c2 equal to d2. A2x plus b2y plus c2z. Okay, a3, sorry I want to use another color for that, no problem. a3x plus b3y plus c3z equal to d2. Matrix form of these equations. So what is that? a1 b1 c1 a2 b2 c2 a3 b3 c3 x y z equal to d1 d2 d3. Okay, so here a1 b1 c1 a1 b1 c1 a2 b2 c2 a3 b3 c3 is called coefficient matrix and denoted by capital A. Next, x y z variable matrix and denoted by generally capital X, and d1 d2 d3 constant matrix and denoted by generally B. That is, this is important, A into X equal to B. This is the matrix form of linear equations. Okay, important thing students, listen. So some linear equations are given. What do you want? You want x value equal to this and y value equal to this and z value equal to this. You want, no? These are called solutions. No? 3 unknowns are given. We want to solve them. So what will we get? For x equal to 2, y equal to 3, z equal to 9. What I can say? 2, 3, 9 are the one of the solution of given system of linear equation. What is the meaning of that? By using this a x equal to b, I want to find x value, y value, z value. Listen students. For example, if you got this matrix x y z matrix, for example, equal to 2 3 9 matrix, for example somewhere you got, then what I can say directly, you can say x equal to 2, y equal to 3, z equal to 4 only. What is the meaning of that? X should be equal to something, some constant matrix you want. What is the meaning of that? From this equation we want to make x as subject. From this equation, these are 3 matrices, we can make x as subject. From that we can find x. If x is subject, no, for example after matrix x equal to, we got a 2 3 4 matrix, I can say x equal to, y equal to 3, z equal to 4 only. What is the meaning of that? From this you want to make x as subject. That is important. Listen students, important. A x matrix equal to B. For example Ax equal to B, then directly I can say B A equal to B by A, because here A, B, C are real numbers. But this is not these are not real numbers, no, arrangement of real and complex number. Directly I can't say that x is equal to B by A matrix. That is not correct. Wrong operation. But how to make x as subject? Pre-multiplication of A inverse on either side. Pre-multiplication of A inverse on both sides. So A inverse into A into x equal to A inverse into B. Friends, the matrix product of matrices will satisfy associative property. That's why I can say that this is x equal to A inverse into B. Okay, A inverse into A means I only, unit matrix, into x equal to A inverse into B. Any matrix is multiplied by unit matrix, that matrix only we will get x equal to A inverse into B. Now we got matrix X. So I made X as subject. Okay, how to find this matrix X? Inverse of A should be multiplied with B. How to find A inverse? Already everyone knows how to find A inverse. If det A equal 0, you can't find. If det is not equal to 0, consistent linear equation, you can solve them. Okay students, listen Nana, if 3 linear equations are given, you want to write it to matrix form. After that you want to take a coefficient matrix, find the determinant. If determinant is not equal to 0, we can solve, we can find solution. In that situation the equations are called consistent linear equations. Consistent means there are again 2 types, no? One is unique solution and infinitely many common solution. What situation this is gives infinitely many common solutions, I will explain later. But unique solution, how to find unique solution, now I want to explain. So what is the meaning? First of all you got det A is not equal to 0, coefficient matrix is non-singular, then A inverse you can find. After finding A inverse, multiplying with B, then you get x. From there you will get x, y, z values. So in this way you can solve a consistent system of linear equations by using matrix method, or sometimes this is called finding solutions of system of linear equations by using matrix inverse method, sometimes called matrix inverse method. So many methods are there. Among them, this is one of the method, that is called matrix inverse method. What is the procedure, algorithm? First, given linear equations are given, try to write them into matrix form. Third one, take coefficient matrix as A, variable matrix as X, constant matrix as B, automatically you get Ax equal to B. From this what I can conclude, X matrix is nothing but A inverse into B. Okay students, afterwards we need to find det nana. Det, if det A is not equal to 0, we can say that they are consistent linear equations, we can solve unique solution only. If det A equal to 0, then what happened? Again he will get infinitely many common solutions or no common solution. So det A equal to 0, then we will get 2 cases. One of them is infinitely many common solutions and no common solution. When we will get infinitely many common solutions, here we need to find adjoint A into B. If adjoint A into B equal to 0, here det A equal to 0 and adjoint A into B equal to 0, then you can say the infinitely many common solutions. And det A equal to 0 and adjoint A into B is not equal to 0, then you can say that that system is doesn't have any common solutions. You can say that inconsistent linear equations. Okay students, so what I explaining here, how to solve linear system of linear equation, that too homogeneous non-homogeneous linear equations by using matrix inverse method. Okay, listen students, first of all we will get Ax equal to B. From this we will get x equal to A inverse into B. Here we'll get several cases. First one, det should find. Det is not equal to 0. Straight away you can say that unique solution. Then you can say that system is consistent with the unique solution. Okay. If det A equal to 0, then it will gives 2. It will gives 2. What is that? It may be infinitely many common solutions and no common solution. When it gives infinitely many common solutions, infinitely many. So adjoint A into B should be 0. This is one of the way. Rank method also there. At last I will explain rank method also. Infinitely many, adjoint A into B equal to, B equal to 0. Okay. No solution. No solution. What? Adjoint A into B is not equal to 0. In this case, you can say that the linear equations are said to be inconsistent system of linear equations. Okay, students. Note: x equal to A inverse into B. First one, that A is not equal to 0, then so I want to take this as 1, that is system of linear equations. Solve x plus y plus z equal to 9. 2x plus 5y plus 7z equal to 52. 2x plus y minus z equal to 0. Students, on here 3 system of linear equations are given. I want solve. First of all, I want to find whether these gives consistent or inconsistent. Actually, these are non-homogeneous. Constant terms are there. Constant terms are there. D1, D2, D3 are there. Okay. Student, important note: to use matrices method, your constant should be right hand side of the equality. Okay, that is important thing. Matrix form of given linear equations. Yeah, directly I want to write 1 1 1 2 5 7 2 1 minus 1 into x y z should be equal to 9 52 0. Let A equal to 1 1 1 2 5 7 2 1 minus 1 comma x equal to x y z comma b equal to 9 52 0. In examination you write a coefficient matrix, variable matrix, constant matrix. That implies A x equal to B or x equal to A inverse into B. But in examination you need to write steps how you got that A inverse, what around pre-multiplication of A inverse on either side, like that. Okay. Now I want to find det A. 1 triple 1 2 5 7 2 1 minus 1. Observe, correct or not? 2 1 minus 1. Okay. So directly you can find, or you can use row transformation or column transformation, your wish. Using transformations or without using transformations. 1 into minus 5 minus 7 minus 1 into minus 2 minus 14 plus 1 into 2 minus 10. Should take care. If you make any mistake here, the problem becomes wrong. Okay, now I want cross check. Minus 5 minus 7. Okay, minus 1. 2 into minus 2 minus 14. Okay, so 2 minus 10. Okay, so here minus 12. This is 16 plus 16 minus 8. So what I am getting? Minus 20 plus 16, that is equal to minus 4, not equal to 0, means given system is system of inconsistent linear equation with the unique solution. Okay, therefore given system is solvable. Okay, now how to find A inverse? How to find x nana? First of all, you need to find A inverse. That is the difficult task for us. So next page I will write A equal to 1 1 1. Here 2 is there. Yeah, 5 1 7 1 5 1 7 1 5 1 7 minus 1. Cross check. 1 2 5 7 2 1 minus 1. Okay, cofactors matrix should find, adjoint matrix should find, det should find. Okay, first cofactor 1 directly I want, right? That is plus into minus 5 minus 7, that is equal to minus 12. 1 1 2, that is minus half. So what is that? Minus 2 minus 14, that is equal to plus 16. Next 1 1 3, that is equal to plus half. Yeah, 2 minus 10, that is equal to minus 8. 2 2 1, that is equal to minus half. Yeah, this row, this column, 1 into minus 1 minus 1 minus 1 minus 1 minus 2, totally 2. Now should take care now while finding these all. 5 2 2, that is equal to plus half. This cancel. Minus 1 minus 2 minus 3, that is equal to minus 3. Next 7 2 3, that is equal to minus, yeah, this 1 minus 2 minus 1, that is equal to 1. Next 2 3 1 should find. Yeah, that is 7 minus 5 2 3 1 plus, once again I want cross check. 7 minus 5 2 plus 2 only, that is equal to 2. Next 1 3 2 I want find. 1 3 plus 2 5, negative number will get. This get cancelled. 7 minus 2 5, that is equal minus 5. Finally I want right here minus 1, that is 3 3, that is a plus only. So what happened? 3 3 5 minus 2 3. Now I want to find cofactor matrix directly here. What is that? Minus 12 16 minus 8 2 minus 3 1 2 minus 5 3. Should take care now, correct only. Minus 2 16 minus 8 2 minus 3 1 2 5. Okay, next adjoint matrix I want right directly. Transpose of this adjoint here directly. Minus 12 2 2 16 minus 3 minus 5 minus 8 1 3. Okay nana, this is adjoint matrix. Yeah, next I want to find A inverse. A inverse equal to, what is 1 by det A into adjoint A. A inverse equal to, what is det? What you got det? Where is that det? Minus 4. Okay, 1 by minus 4 into minus 12 2 2 16 minus 3 minus 5 minus 8 1 3. Important note, student, don't multiply with this constant. At last you can multiply, don't multiply here. So x equal to A inverse into B. So A inverse means don't multiply with this. Okay, that is important. Minus 12 2 2 16 minus 3 minus 5 minus 8 1 3. What is matrix B? Where is B? 9 52 0. Bab 9 52 0. That's why another methods are invented, Nana. By using determinant methods also you can find. Okay, so minus 1 by 4 into, students listen, this is 3 by 3 matrix, this is 3 by 1 matrix, 3 by 1 matrix, here one element, here one element, here one element only will get. So I want find what is that. Okay, first row with first column, 12 nines are 90 18 minus 108 plus 52 twos are 104 plus 0. What will get done here? I think minus 4. This is minus 4. Okay. Next, second row, 16 nines are 54. Correct only? 9 6 are 54. 9 ones are 144. 144 minus 52 3s are 6 minus 156. Cross check. 3 are 6 15. Okay. Next, minus 0, no need to write that. This, what is the here? 50 minus 6 6 minus 12. I think correct only. Yeah. Next, last one, 9 8s are minus 72 plus 52 0. This is 52 72 minus 20. Minus 20. So what is this, Nana? This X matrix. No, I want to write X matrix. Now we can multiply. What will get here? 1 will get, here 3 will get, here 5 will get. After that, X, Y, Z equal to 1, 3, 5. We need to write one step, Nana. By the equality of the matrices, X is equal to 1, Y equal to 3, and Z equal to 5. So sometimes we need to cross check. So your solution may or may not be correct. No, cross check. Substitute in the given equations and cross check. What I got, I will write here. What I got here. So 135. 135. I will write here. 135. So 1 plus 3 plus 5. Okay, this satisfied. Any one of them. Last one. 2 plus 3 minus 5. 0. Okay. So what you got correct only. No? Like that we need to check second equation also. So in this way you can solve the consistent non-homogeneous linear equations by using matrix inverse method. Okay.